Hi everyone, I hope you're okay, and I really hope guys that the videos will keep uploading. They are helping you out. If you are new to the channel, please guys don't forget to subscribe, and if you like the content, don't forget to like the video, and please share to your peers so that the channel will grow and reach a lot of people. Okay, uh today's video guys is about learning how to calculate pH. Specifically, this video will be about learning how to calculate pH of an acidic solution. Are we together? The equation to calculate pH simply says pH is equal to negative log of the concentration of hydronium ions. Are we together? Please guys, do not make the mistake of substituting the concentration of the actual acid here. We only substitute the concentration of hydronium ions. Are we together? Yeah. So for you to be able to calculate pH, you must be able to find the concentration of hydronium ions, then substitute. If your solution is acidic, I'm expecting your pH to be between 0 and 7. Are you together? If you're calculating pH of an acidic solution and then you find that your pH is above 7, there's something you did which is incorrect there. Okay, let's rather jump into this example. We are told that 21 grams of 500 cubic centimeters of nitric acid is prepared for an investigation in a beaker. Calculate the pH of the acid. Okay, the first thing here guys I will need to do, I must calculate the number of moles of my acid, and then use my stoichiometry to find the number of moles of the hydronium ions, and then later find the concentration, and then find the pH. But before I do that, I must write down the ionization of my acid guys. Remember that nitric acid is a monoprotic acid. It ionizes to donate a single proton. So I'll have H3O plus the nitrate ions. Okay, so I'm given 21 grams of the acid, so I can simply calculate the number of moles of my acid. I'll say that's 21. I will use the equation that says number of moles is equal to mass over molar mass, mass over the relative molar mass number. The number of moles is 21, and the molar mass for nitric acid, I have 1 for hydrogen, 1 for hydrogen, 14 for nitrogen, and then I will have 16 multiplied by 3 for oxygen. So the number of moles, let me punch my precious calculator, 21 divided by 1 plus 14 plus 16 times 3. I'll simply get 0.33 moles. I'll simply get 0.33 moles, right? And then after finding the number of moles, I know that 1 mole of nitric acid will give me a single mole of hydronium ions, right? But now I do not have 1 mole of the hydronium ions. I have 0.33 moles. I want to know how much of the hydronium ions will I form. Simply cross multiply, then X is equal to 0.33. But remember that X also represents the number of moles of my hydronium ions, H3O plus. Are you together? So therefore, for me to find the concentration of my hydronium ions, I know that concentration is equal to N over V, which is simply 0.33, and the volume, this thing is inside 500 cubic centimeter volume. So I'll simply convert my volume into cubic decimeters. 0.33 divided by 0.5, I'll simply get 0.66. This is the concentration, moles per cubic decimeter. This is the concentration of my my hydronium ions, right? So therefore the pH is negative log of the concentration of hydronium ions, negative log of 0.66. What do I get? Negative log of 0.66. I will get 0.18 as my pH. There is another way, guys, to do this. I could have calculated the concentration of my acid right away. Let me do this. Concentration of my acid is mass all over the relative atomic mass number multiplied by volume. Yeah? The relative atomic mass number, let me calculate 1 plus 14 plus 16 times 3. Okay, it's 63. I want to find out the concentration of my acid, right? Concentration of HCl. The mass is 21. I have 63. And the volume is 0.5. So for me to find the concentration, I'll simply say 21 divided by 63 multiplied by 0.5. So I'll also get 0.66 moles per cubic decimeters, right? I can use my stoichiometric calculations. I know that 1 mole per cubic decimeter of HNO3 will give me 1 mole per cubic decimeter of H3O plus. Remember that this guy is a strong acid, so it ionizes completely. All together. So since I know the concentration is 0.66, I have X there. So X, which represents the concentration of H3O plus, is 0.66. The concentration is 0.66. I had 0.66 there. So the pH will be the same. So whenever I calculate the pH, negative log of the hydronium ion, negative log 0.66, I will simply get 0.18. That's how, guys, you calculate pH of a solution. All right, together. Just to make sure that you have grasped the information, you can pause the video and try to tackle this question. We are told that 0.5 moles of a 600 cubic centimeters of hydrochloric acid is present in a beaker. Calculate the pH inside the beaker. Okay, the first thing, guys, you need to do, you must write down your ionization equation. I have HCl plus H2O. This is in aqueous solution. This is a liquid. This will give me H3O plus, which is aqueous solution, plus the Cl minus. Okay, I do have the number of moles, guys, of my acid. I can simply use my titration equation. I know that 1 mole of HCl will give me 1 mole of H3O plus. Are we together? So now I have 0.5 moles of HCl. I want to know how many moles of H3O plus will I have. Simply cross multiply. Then X, which represents the number of moles of my hydronium ion, will be equal to 0.5 moles. Now I do know the number of moles. I can simply calculate my concentration and then find the pH. So the concentration of my H3O plus, remember that concentration is number of moles over volume, right? So I have 0.5 all divided by 600 cubic centimeters. I'll simply say 0.6. What do I get? 0.5 divided by 0.6. I'll get 0.83 moles per cubic decimeter. So therefore my pH will be equal to negative log of the concentration of hydronium ions, which is simply negative log of 0.83. What do I get? Negative log of 0.83. I'll get 0.081 as my pH. The main thing, guys, you need to do is to calculate the concentration of your hydronium ions, and then you will find your pH. And remember that, guys, I did tell you that if your pH is greater than 7 and you have an acidic solution, that means there's something wrong you did. Okay, number 2, we are told that two contents of beaker A and B are mixed together in beaker C. Calculate the pH in beaker C. E. Okay, since we are mixing two acids, guys, it simply means that there will be no titration happening together. So since both of the acids they give a higher concentration of hydronium ions, it simply means the solution in beaker C will be highly acidic because it will have an excess number of hydronium ions. So for us to find the pH, we must be able to calculate the concentration of the hydronium ions inside beaker C. For us to find concentration, it will be easy because we do know the volume in beaker C. The two volumes will add each other here. We'll have 500 cubic centimeters plus 400, and then we'll have 900 cubic centimeters, right? And then the only thing that you are short of is to find the total number of moles of the hydronium ions present in beaker C. How can we do that? Let's start by dealing with beaker A. I want to calculate the number of hydronium ions which were contributed by beaker A into beaker C. I know that my acid is a diprotic acid, right? I have H2SO4 plus H2O giving me 2H3O plus SO4 2 minus. There's also a 2 there, right? I can calculate the number of moles of my acid. So let me use a blue color or black. Yeah. The number of moles of my acid is simply concentration multiplied by volume. My concentration is 0.1 and the volume is 0.5. So the number of moles, I'll simply say 0.1 multiplied by 0.5. I simply get 0.05 moles. Are you together? But what do I know? What do I know? I know that I simply know that 1H2SO4 will give me 2 of the hydronium ions. Are you together? So now I have 0.05. I want to know how much of the hydronium ions will I form. Whenever I cross multiply, I'll find that X, which represents the number of hydronium ions that I formed, is simply 0.1. Yeah, simply 0.1 moles. So this thing, guys, simply tells me that beaker A has contributed the number of hydronium ions, which is equal to 0.1. Now I want to find out the number of hydronium ions contributed by beaker C. By beaker B rather, the second beaker. I have nitric acid, which is a monoprotic acid, NHNO3 plus H2O will give me H3O plus the nitrates ions. These are reversible reactions. I can calculate the number of moles of my nitric acid. It's simply concentration multiplied by volume. I have 0.2 multiplied by 0.4. I'll simply get 0.08. Let me confirm. 0.2 times 0.4. Yeah, that's 0.08 moles. But what do I know, guys? I know that 1 mole of nitric acid will give me one proton. Are you together? So now I don't have 1 mole, I have 0.08. I want to know how many protons will I have. So X, which represents the number of protons or hydronium ions, is equal to 0.08 moles. This thing simply means that beaker B has contributed the total number of H3O plus ions, which is 0.08. So this thing simply means that, guys, in the final solution in beaker C, the total number of moles of hydronium ions that we have, the number of H3O plus, we'll add these two, 0.1 and 0.08. So we'll simply have 0.18 moles in total. Are you together? So now we can simply calculate the concentration. So let me write it in red. The concentration of the hydronium ions in the final solution of beaker C is simply number of moles over volume. It's 0.18 divided by 0.9. Remember that, guys, now I have 900 cubic centimeters because the volumes are additive. So I have 0.18 divided by 0.9. This will give me 0.2. So therefore, the pH of my solution, negative log of the concentration of hydronium ions, is negative log of 0.2. What do I get? Negative log 0.2. I get 0.6987. which is simply 0.7. The pH of my solution is 0.7. These questions, guys, are usually they're typically 7-8 marks, né? But all you need to know, since there's no neutralization taking place, you must calculate the number of hydronium ions which are contributed by each beaker into beaker C, and then find the concentration of those hydronium ions and then find the pH. That's all you need to do. Then the last question, guys, we are told that two contents of beaker A and B are mixed together in beaker C. The pH of the final solution in beaker beaker C is 1. Calculate X, the concentration in beaker B. Okay, we are mixing hydrochloric acid and phosphoric acid, right? Okay, I already know that the volume in beaker C. Okay, so this is A, B, no, it's A, B, and C, right? If you work with beaker C, right, we can calculate the concentration or the concentration of the hydronium ions present there. Remember that we are adding two acids, hydrochloric acid and phosphoric acid. There's no neutralization happening. We'll just have an excess amount of hydronium ions. Since I know the value of my pH, I can simply calculate the concentration of my hydronium ions. How can I do that? I know that pH is equal to negative log of the concentration of the H3O plus ions. For me to find the concentration, guys, please don't worry about the maths. You'll always say concentration of H3O plus is equal to 10 to the power negative pH. Right, together. So in this case, our concentration will be 10 to the power negative 1, which is just 0.1 moles per cubic decimeter. Now I know the concentration of the hydronium ions inside beaker C. I can find the total number of hydronium ions present in the final solution of beaker C. How can I do that? I know that concentration is always N number of moles over volume, right? The concentration is 0.1. I don't know what the number of moles are, but the volumes are additive. I have 500 cubic centimeters of HCl and 450 cubic centimeters of the phosphoric acid. So basically I have 950 cubic centimeters, which must be converted into cubic decimeters. That will be 0.95. So the number of moles is 0.1 multiplied by 0.95. I'll simply get 0.095 moles. All right, together. So the number of moles here, the number of moles of hydronium ions, H3O plus, is 0.095 moles. All right, together. So for me to find X, I must at least know how many moles of hydroxide, how many moles of hydronium ions were contributed by the phosphoric acid into beaker C. But remember that I do have a standard solution there in beaker A. So I can simply use the information in beaker A. The number of moles of the hydrochloric acid in beaker A, concentration multiplied by volume, 0. the number of moles, excuse me about that guys, the number of moles present in beaker A of the acid is 0.09, which is the concentration, multiplied by 0.5, which is the volume. 0.09 multiplied by 0.5. I'll simply get 0.045 moles. My acid, guys, remember that hydrochloric acid is monoprotic. Hydrochloric acid is monoprotic. So hydrochloric acid will give me one H3O plus ion. So I know that one HCl will give me one H3O plus. So if I have 0.045, I want to know how much will I have of the hydronium ion. I'll just cross multiply. X, that represents the number of hydronium ions, will be equal to 0.045 moles. Alright, together. So now I know that the hydrochloric acid has only contributed 0.045 moles of the hydronium ions, but in total, guys, I had 0.095. That means the other part came from beaker B. Alright, together. So I'll simply say the number of hydronium ions in beaker B will be the total in beaker C, which is 0.095, minus the number of moles which are contributed by beaker A, 0.045. I'll simply get 0.05 moles of the hydronium ions. Are you together? So which simply means that this guy contributed 0.05 moles of the hydronium ions. But remember that, guys, phosphoric acid is a triprotic acid, which simply means it gives away 3 protons, right? So H3 PO4 plus H2O. This will give me 3 of my hydronium ions plus the phosphate ions. Just put a 3 there to balance, né? Okay, so since I do know the number of moles of hydronium ions, I can simply find out what is the number of moles of my actual acid. I know that 1 mole of H3PO4 will give me 3 moles of the hydronium ions altogether. But now I do not have 3 moles of hydronium ions. I had 0.05 of my hydronium ions. I want to know how much of the acid did I have for me to produce 0.05 of the hydronium ions. I'll just cross multiply. Then 3x is equal to 0.05. Then x 0.05 divided by 3. Then x, which represents the number of moles of my acid, is simply 0.0167 moles. Are we together? And then therefore I can simply find the concentration. I know that concentration is number of moles over the volume, 0.0167. The volume is 450 cubic centimeters. That's 0.45. So 0.0167 divided by 0.45. Uh, 0.0167 divided by 0.45. I'll simply get 0.0 0.03711, so it's just 0.04 moles per cubic decimeter. This is X. Okay guys, let me take you step by step, because maybe I might have lost some of you. The first thing I did was to calculate the concentration of the final solution in PKC. Ne? Why did I do that? Because I wanted to calculate the number of moles of my hydronium ions which were present in PKC. Are you together? And I found them to be equal to 0.095 moles. So the 0.095 moles is the sum of the number of hydroxide ions which were contributed by both beaker A and B. I can find the number of moles which are contributed by beaker A. Remember that beaker A is a standard solution. I have the concentration and the volume, right? So I did calculate the number of moles of the acid, and since I know that my acid in beaker A is monoprotic, so the number of moles of the acid will be equal to the number of moles of the hydronium ion. Are you together? So I found out that the number of moles which were contributed by beaker A was 0.045. So that means the difference will be contributed by beaker B, and the difference I found it to be 0.05. Are you together? But please remember that the 0.05, guys, is not the number of moles of the acid. These are the number of moles of the hydronium ions. Are you together? So now I do know the number of moles of my hydronium ions. I can simply find the number of moles of the acid. Remember that, guys, phosphoric acid is a triprotic acid. It ionizes to donate 3 protons. Are you together? So I just use my ratio and proportion to calculate the number of moles of the phosphoric acid, and then I found the concentration of my acid, which is equal to 0.044. I hope, guys, the video was helpful. There will be a series of videos following this one whereby I will be answering past question papers. Just stay tuned, guys, and wait for more videos. Thank you.